How's it going, everyone? Welcome to another video on Typescript Pro Essentials. Euriel Gonzalez here. Thanks to Matt Pocock. That's a funny last name. Anyway, so he made this course, right? And to me, in order to get myself familiar and understand the nature of Typescript, what is the problem that it solves, I have to dive into the origins. And that makes a lot of sense because now you can understand where the things is coming from or where the things come from, so you can now get a much more sense of where the things is going to, right? So the TLDR is that because TypeScript was developed by a bunch of Microsoft engineers back in 2011, since they have extensive experience writing uh, type safety code in compiled language like C sharp, when you have all of this different annotation on the language, which when I was exposed back then in 2007, I really love about C sharp language. And it's because it gives me now the intuition, it gives me now insights of the intention of the code. I just only needs to read about that. That's all. I don't need to actually remember something. The intention is there. Okay? So, what this team back then did was to actually create a superset of JavaScript that includes now this typing and this type system annotation, right? So, uh, right now, in order to use that, there are now two development ways. Whether you're using JavaScript without any TypeScript, all right? This is something that now browsers can understand, and once you now put that series of valid JavaScript statement, it will work. So the browser will understand and then do whatever those statement does, right? However, as your application is grow and is scale, and that you're starting to now serving not only thousands or tens of thousands users, but now millions of users, you need to have some. You need to find some ways to make this easy to debug, to maintain, and to enhance, right? And this is what this compiled language offers, because unlike now JavaScript, where this is a dynamic language, so you can mutate things in there, so for creating prototypes is good, but when it comes to those prototypes have to scale up, now you have some sort of guardrails and standards or practices, right? So that's why now TypeScript here and say, hey, the development workflow is, or the TypeScript workflow is, since you're not writing JavaScript code, you are writing is this superset of JavaScript. Now, you have is the development mode, and also you need to somehow transform that into some evergreen JavaScript code for browsers, right? So you have now two scenarios. The first is the development. So usually we use now a Visual Studio Code to, or an IDE, most likely Visual Studio Code, or it can be WebStorm, you name it. But in any case, it is an IDE, integrated developing developer integrated developer. Oh my god, integrated developer experience. No, that's not an ID. Oh my god, did I lose my mind? An ID is an integrated developer environment. Exactly. It's an integrated development environment. That's right. So VS Code is one of the most common on the web, right? So here now, with this environment, we can now use several plugins to enhance the experience of this environment. So one of them is setting a Typescript server that when it detects any Typescript files and when those files change, so now it provides some hints. This is known as the Typescript server language. So this actually is now the development. So you write your code on your ID, and then the ID runs a Typescript server that's checking for any common errors in your Typescript, right? So, and then once that is done, you now have to transpile, which is a fancy way to convert one program, high level program, into another high level program, from Python to JavaScript to Ruby to Rust to C++ to JavaScript, and in this case to JavaScript. So now you also need to bundle up that code, make it ready for delivery, and also widely acceptable for the vast majority of browsers out there, right? Now, I went through describing this particular process, at least in the current state of 2026, 2025, 2026, using and setting up the VS Code, as well as some plugin that Matt Pocock actually created for VS Code to make it much more intuitive when it comes to describe is errors, Typescript errors, right? So make it more human readable like. And then we need to somehow run our files in and to automate some tedious and monotonous task. So anytime that you write a file and that it is ready, you need to actually is transpile into a JavaScript. And the other is that anytime that a file change, you want to do is um, uh, check if that file is correct. That's why we use now the Typescript compiler here to help us to watch. So we run this Typescript server to watch our JavaScript file, Typescript files, and when they change, now we can actually is after that generate is the proper JavaScript files. So because now in order to integrate is these two scenarios or these three scenarios, the development, the testing your code, and then the production into one single workflow, Vid has shown and has learned from the industry of how to do so, right? Or at least to integrate the most common environments into one single pipeline or using one single tool, which is how you set up your dev server from scratch, how you now reload the browser anytime that a file change, known as the hot mode reload, and then how you now is generate the JavaScript files. So this is what we use Vite. We also Vite comes with some other testing that go beyond the scope of today's video. But this is just to understand is now where we are. Okay, and then finally is getting into the habits of understanding is the type system. So JavaScript, this is more relevant to JavaScript, but JavaScript can be split in three main areas: the type system, the scope, and the scope, and aka is the scope analysis and the parsing or the scope, all right. And then is the objects and classes. So why my mention is this? Because on the type, which was we really care in today's video, so JavaScript has several types, or aka primitive. So string, number, boolean, big int, in symbol, as well as kind of emptiness, like undefined and null, and the objects, which is not a primitive, right? And on the objects we have is several type of data that can inherit from this object, right? Whether it is, how do you describe now a collection of values as an array, or as a hash table where you can have is key and the value, and that value can be any primitive or even another object or even a collection, right? And also functions. So so here, that's why we look at the essential types and notations. So first look at how we understand now functions errors to get ourselves familiar with that. All right, so we start with functions, looking at annotation with functions, some of the parameters annotations, the parameter annotations, exactly the parameter annotations, the common basic types in JavaScript, the optional type, or the optional function parameter, the default parameter by passing is now the equal value, and then typing object literals. And here is you define is like this. You define is a type or an interface. Usually you use a type to define is a new type of value. All right. And then now making object property optionals and using now the definition file to act as a single source of truth, and then defining now an array into an object, how you can do that, and the different ways to do that, whether you're defining as an array or as a square brackets. There also is a third one. I am not quite familiar with that. Yep.
In this exercise,
yeah, I am not quite familiar with
function
that.
down the bottom with.
Um,
Okay, there are actually two different syntaxes here, and this is array is kind of like a type function here, and we're passing string to it. We can pass a number to it if we want to as well.
Exactly. So this is interesting. So we can specify is either using is a curly brackets, right, or this some sort of type functions like an array.
But this syntax, you're going to see this kind of a lot as well, and there's an open debate in the TypeScript community as to which one is better. I'll link to an article below where I dive into exactly all of the differences. I think this syntax is really useful to know because this is going to come up later as well when we look at like promises or record.
So anytime that you see this kind of stuff, you say, hey, this is now a function type, all right? But it's in a specific type that allows to define is a value type in that, right?
Or things like that. So this type of syntax with the angle brackets is very, very common in TypeScript. But given that we have this beautiful sort of like angle bracket syntax, I kind of like using this. And this is what the TypeScript error messages say as well. So if you're reading something in TypeScript, you're most often going to see it represented like this with the angle brackets, or sorry, the square brackets at the end, rather than with the angle bracket syntax here. So because of that, I tend to prefer the square bracket syntax.
I tend to prefer now the function type because now is kind of making obvious of what am I doing and what TypeScript is doing, and to make sure that this is now a function type provided by a TypeScript, right? And this is interesting because now it opens up It's a new world of possibility in terms of that you can create your own function types and generate now dynamically or figuring out what are the properties that you want to get from this, right? So now these function types, as something that we're going to see that later on known as genetic, is the way of how you can now derive or cherry pick some couple properties useful for complex objects, or in this case, with objects, whether it is a hash or a set or a function or a what an array, right? So, and we also talk about is now how you can define is collections inside of your types. All right. And
So I've written
he
down
mentioned is couple one,
and we get a sort
right?
of sense of.
So you're defining is now like the basics piece of information. So exactly. So it's interesting. There are three ways of how you can now is define is, yeah. So there are three ways how you can define is this ingredient stuff, or how you can define. This is why I asked. This is a good question. How do you, for example, define ingredient here using now that let's get into this. This is where I would like to dive in into today's topic. So, for example, how do you now make sure about this? So we can is define is the specific shape of this of each one of those elements. In this case, hey, the specific ingredient type. It is made of the name, which is in a string, and the quantity, okay, which is another string. And then what you can do is something like this. Hey, instruction, or in this case, ingredient, all right, is now an ingredient, okay, but you can define it either as a square bracket, right, to say, hey, this is now a sequence of all of these elements. This is the shape of all of these elements. Or you can say now something like this. Hey, this is now an array, a type function, where each one of those elements will be of this shape. Ingredient, right? So both of this way are valid. Okay, that's interesting. It failed because, of course, it failed. Now that you got it. Oh, of course it failed because there is a missing bracket here. There you go. So this is now when you are defining is okay. When you are defining is your object literals, okay, or object notations, and then look at the array notations. All right, and how you can define now is array notation with a different type, with a different primitive, right, which is a more complex shape. This is how you can define this. And I do find this way much more intuitive or more useful to read about rather than this, okay, rather than this notation. Again, this is something that is straightforward. But the idea of Typescript is that now we can see the intention of the author. And if you can imagine that you have another different data structure, all right, that is made use of this. So, for example, something like user, and that user now follows some specific. Let's say this user now is some sort of specific collection of elements that now is going to each one of those elements will be of this type, of this shape. I know I go beyond the scope of today's video, but the thing here is that with this you are defining the type of this function, the array type function, and then now follow the specific shape of that, right? We can also define something like object. I'm not sure if object, that would be a very interesting thing to explore, at least right now in Typescript land. When we say, hey, no, this is more like class member fields point good greater, okay, greater. Class derived extend base. No, again, I do wanna look is at the, not the basics, is the reference, the utility types. That's right, the utility types, which is some specific function type that Typescript offers to you. So you have also the decorators, all right, as a way to do this. But particularly what I really care right now is on the cheat sheet, flow, control flow analysis, interface, type, and class, right? Our particular is the, no, this utility types, right? So we have several of them: partial, require, read only, records, pick, omit. Now things started to make a lot of sense. Okay. This type, intrinsic string manipulation, uppercase string type, lowercase string type, and so on. So okay, template literal string. Okay. Map type. When you don't want to repeat yourself, sometimes a type needs to base on again. Chill. Right now I'm just looking at this is type manipulation, but I'm looking is just at the type functions. All right, so chill. Access property, generic object, and these generic object types. Let's imagine a box that can contain any value, string, number, and giraffe, whatever. Right now the contents property is type any, which but can lead to accident down the line. We could instead use unknown, but that will mean that in case when we already know the type of the content, we needs to do precautions check or use error-prone type assertion, like this error-prone type assertions. Or one type safe approach will be instead of scaffolding out of different boxes for every type of content, like this, number box, but that means that we'll need to create different functions or overload of functions to operate on this type, right? So we have to create now different signatures, function signatures, to operate on this type, and that is a lot of boilerplates. Moreover, we might later need to introduce new types and overloads, aka more signatures, and this is frustrating since our box types and overloads all are effectively the same. Instead, we can make a generic box, all right, type which declares a type parameter, which you're going to now provide this as the shape of this, and you might read this as a box type is something whose content have the type. Okay, a box of type. Okay, a box type, or in other words, we look right now here. Let me plug in this. That's right. So if I plug in here an array type like this, an array of type, right, is something whose content has type. So an array of type is something whose content is ingredient. And think of box as a template for a real type. Where type is a placeholder that will get replaced with some other types. And again, this goes a little bit beyond the scope of today's video. But the thing here is now we can actually is dynamically generate types, pretty much like functions, generate values with types. We can generate now is types, all right, dynamically generating types. That is a mind-bending stuff. And as you can see here, the array type is something that is by far the most common use case. The other is the read-only array. All right, that's also quite interesting. So if you want to do some manipulation, it doesn't allow you to do so. In other words, you say, hey, if you want to somehow generate new values, no, recreate a new one. And much like the read-only modifier for property, it is mainly a tool we can use for intent. When we see a function that returns read-only array, but in any case, you get the idea. The other is tuple, all right, which is part of the nature of the objects in array. Okay, so JavaScript now split arrays and objects into types. In objects, you can have object has records where you already know in development all the different property of that object, where their value can differ. And the other is now dictionary, where you don't know. I mean, that's dictionary, and record, and like record. So so dictionary is when you know all of the property in advance, all of the key in development at development. Whereas record is when you are not sure what will be the length of property of this object, but at least you know what will be is the value. So in the case of array, right, you can have is now a list, which is an X amount of elements that you don't know that, right? It can be, it's dynamic, right? But unlike tuples, that you know the limit, you know the size in advance, but each one of those elements might differ. And this is what tuples kicks in, you know? hmm So again, I'm just ahead of the curve right now. But it makes ton of sense to at least get to understand how you can use now is how you can define arrays in objects and the different ways to define that, whether it's using a curly braces or the type function like the array, and then explore more about is the rest operator or and how the rest operator actually works, not only on functions but also on other places. For example, when you want to spread elements there. But again, it's looking at the rest parameter. As I mentioned, also is the tuple. How now is the tuple works? Why do we even care about tuple, which is useful for geographic locations and working with anything related to that, right? Any x, y, or latitude and longitude. That makes a lot of sense to store that into a tuple, right? And how we can define some tuples here. Just as you can see here, we already have a specific way to do so. It's interesting because there is no specific genetic function. That's quite weird. All right, there is no specific genetic functions to define our tuples, unlike array, which will make sense to do that, but in any case, they don't define that. But here's how you define it, right? As an array as it is. The optional tuple members, right? Which is adding is a specific, so here in the exercise, is now adding to the tuple here. So instead of saying array of number, you now explicitly say, hey, this is now a tuple that what is do something with latitude and longitude and elevation in here, right? So for example here it say, hey, I do expect that the first value exists, the same for the second, but the third one is optional, right? So this is how you can now explicitly tell to this tuple data structure, hey, please do this, right? And the other is a controversial any type. So why this is not a good idea, right? Because you can enter into some sort of unexpected bug because now thing doesn't work the way it's supposed to, and especially when you do some type conversion, type coercion.
In this exercise, we're going to look at any, a very famous, very useful, but very controversial type in TypeScript. We have a handle form data function at the top. We're calling e.preventDefault to prevent anything default happening with that form. We're creating some form data out of that form, and then we're basically saying creating an object from that form data and returning that object. In our tests, we have a document.createElement form. We set the inner HTML to add an input. Then we manually submit the form, and when it submits, we expect the value to equal the value that was in our form that we sort of grafted in there. So this isn't the normal way that you test forms, but I wanted to do this to basically really test out our handle form data, and something's gone wrong. There is an error in this setup somewhere, but we don't quite know where. So your job is going to be to take a look at this, see if you can figure out why this error is happening and debug it. And while you're at it, see if you can figure out what this any is doing for us, if anything.
So the idea is this is useful, this is interesting, especially because you're gonna look a lot of the time in any type when some developers say, hey, you know what? I don't know what is this. I just want to pass the test and move on along. Uh, but when you are detecting some specific events on the browser, and you don't know what is the shape of what you are getting from, but you know there is something. um, Usually, when you now create is a form, right? So here we create now a form, and then we add inner HTML. What it's doing here is just injecting HTML. For security reasons, we shouldn't do this, but we are doing that because we want to now is add into this stream and parse that as an HTML. So now it's making this, all right? And when you submit the form, I want you to now call this function called handle form for me. So yes, I don't want us to prevent any default behaviors. This go beyond of today's topic, but the TLDR is that before we have fetch or even JSONs, the way how you now send data from the client to the server back in the early 90s is using now a form. So that's why they have is the form actions to define is the path to send this data, all right, and the specific verb that indicate, or HTTP verb that indicate that communication, how it's going to be, right? I'm gonna get some data, or gonna post some data, or gonna update via patch some data, or gonna delete some data, right? And and especially here, because if you say, hey, this is a form on submit, the thing is that you don't, sometimes you want to know what is the shape of this value. That's where I see this convenience stuff, um, especially for handling this event on the browser, okay? That I see this quite convenient, especially if you want to fix something or enhance something quickly, right? But the thing here is with any, well, we don't know what is this. So by exploring here and say, hey, E has a type of E, right? Uh, and here, look at this. It say, hey, now this is a call submit event, all right? So locally for us now is detecting that, right? It's saying is this parameter that I'm detecting. So Typescript say this is a submit event. So if we say now this is a submit event, all right, and then we try to debug this and say, hey, property target does not exceed in submit event target. You mean that? This is one of the useful and lovely things, because this event now is showing what are the things that we can do here, right? So if you can, as we explore here, we have all of this. And the thing here is that, okay, what is this submit event at the end of the day? Where are these things is coming from? So this is why I have to look at the, or to have a mental model, especially when you're working now with JavaScript, TypeScript on the browser. Okay, so what is the shape of this? What is the visualization of how do we have? What is the hierarchy? What how does it look like? All right, what is the map of this? And it turns out that according to the web living standard, the IDL, something like that, is the web IDL. that stands for the interface description language. That's right. So it's a form. It is a format for describing APIs here, right? So this for the browsers, okay, to be implemented by the browsers. So because now the browser has to follow this API implementation, and one of them is the events. And you can look at the MDN docs or even the web IDL here, which is the living standard here, of all of the different of how now web APIs must be implemented. All right, interface definition, you have the names, right? How you now define all of these different names, right? So interface, and also as well as the interface, right? Example, consider the following two interface A and interface B, and describing is how all of this is supposed to work or must work. But here you have is this interface definition language. So you have the members, you have the contents, attributes, operations, overloading, namespace, dictionary, enumerations, types, right? How now the browser is going to handle that to set the value of infra type corresponding on how constant and the type that are represented. If you move down here, you say, hey, JavaScript bindings. What is the JavaScript environments? How you're going to define that API for them. So you have now the interface, legacy callbacks, yada yada, right? The JavaScript type mapping and all of the different types maps that it can have, right? As you can see, records and promise and extended attributes, legacy, security, overload, resolution algorithm, interface. Again, all of it's relevant to the JavaScript. And then the common definitions, right? Extensibility, legacy, and so on and so forth. But in any case, but in any case, right? This section describes a language, which is the web interface definition language, which can be used to define interface for API in the web platform. A specification to define web APIs can include one or more IDL fragments that describe here. This different kind of definition can appear in IDL fragments or interface, partial interface, diggy, and so on. But in any case, when you try to look at the event, all right, it's actually not that it's not descriptive. It's not that descriptive. You know what I mean? But what is describing here, right, on the DOM interface, is something that you have to read down deep to this. But luckily, for me, now this website actually summarized that, and they say, hey, the root of this hierarchy is the event target. So all of this is just to know what is the anatomy of this document. And it turns out that the anatomy is start everything with the event target. So here the describing is the event target as it is, right? The interface event target. I don't know where they're getting that. You know, I don't know how it gets there. The DOM living standard. Oh, I was looking at the web living standard. That's different. The web living standard. Holy fuck. That's different. That's different. That's different. Oh my god. Okay. I was looking at how they define the web APIs. Okay. But in my case, what I care about is the exactly I was looking is at the web spec, right? So this is not relevant for me, okay? Not as a developer. What is relevant for me is the DOM, bro. How the document is organized. This year. You know, how the document is organized. It makes a lot of sense. Okay. Is this one. So how the document is organized. The DOM, document object model. And then you got is this. So this is the infrastructure. It uses now trees. In tree order is pre-order, that first traversal of a tree. So it's describing is how it's going to actually move around this data structure to find that element. And an object that participates in a tree has a parent. And again, it's describing what the French told is a tree. Also is the order is set. Okay. Takes a string input and runs this step, and the other is selectors. And then name validation. Okay, makes a lot of sense, you know. Makes a lot of sense. Makes a lot of sense. Okay. DOM define a platform neutral model of for events, aborting activity, and nodes tree. This is the infrastructure and the event, right? And it all start with this. Exactly, with the event. So the hierarchy of the DOM, how this is organized, it start with the event. And as you can see, well, you also have now some other different, the architecture here. Okay. The DOM living standard. So each one of those know how they behave, what actually they means, mutation observer, interface and interface document, the document types and all that kind of stuff. And all of these different interfaces are part of the nodes, which indeed comes from the event. So when I look at this, right, that everything comes from the event target, and then from the event target, right, you have now the node, and this node, what is representing is each one of those elements into the document that now it can be either is a document, or it can be either is an element or a character data. So what I mentioned here is that something that especially when you are working with forms and you want to detect which event is this, and it tell me here is that this is a submit event, and to me it's like what in the French though is a submit event that come from here, and this is an special type of event handling is form. So the way how this form, or the way how the browser detect those changes, right? That'll be actually quite interesting to look at that and to inspect that. So that's why I actually mentioned this. Inner HTML actually does a full override, and here is now parsing this element into an HTML element, text content with pure text. That's why most of the time it is preferred to use text context rather than inner HTML. Not only because it's slower, but it's parsing the content, so you can prevent, so you can have some XSS attacks to that. The hidden property, and so on and so forth. Some specific tests to know how to do that and how to read this. So yeah, that's interesting, and a lot of people actually are now doing is this stuff, and so on and so forth. Good. There is another question here. Chapter document. That is not only the DOM tree, where in fact I was looking is at the introduction to events, right? And this stuff here, introduction to browser events, and also how now the browsers capture those events, which is the bubbling and capturing here. And this is how now the browser actually is detecting is who triggers what. Similar for React, and I know that this is not a course of React, but similar when you now define, if you are familiar with React, listen to this. Similar when you define a state on a component and then somehow you update that state. Well, this is pretty much similar of the events. So the browser somehow is detecting who triggers now that by going down to that element, right? And then now bubbling up this event across different elements until it reach to the top. Okay, so this bubbling effect, where to me is like quite interesting. Why do we even have bubbling? All right, you can even stop the propagation there. And this is the other is the different the phases of the events. So one of them is capturing, right? The DOM event describe. Look at this. The DOM event describe. UI events are those typically implemented by visual user agents. Visual user agents for handling user interactions such as mouse or keyboard input. So, but in any case, this is the process. The standard DOM event describes three phases of event propagation: capturing phase, target phase, and bubbling phase. On the capturing is identifier, the event goes down to the element. The event goes down to the element. The target phase, the event reach the target element. That's interesting. Okay. And then the events bubble up from the element. And then the events bubble up from the element. I do think that this is, until now, we only have talked about bubbling because the capturing phase is rarely used. And if you think about the bubbling phase, right? Right? So, but in any case, if you think about why do we have now, so how do you handle this, right? Let's think about this for a moment. How do you handle this? So to define which event triggers what, right? So you somehow need to is traverse that element, right? Traverse that. So somehow you need to couple things. Know who triggers that, all right? Or you either have some sort of place to store all of this information, or you just going down looking for that element and then now bubbling up. And on the bubbling up is to actually is to trigger any events that might be at the top of that. Bubbling and capture lay the foundation for event delegation, an extremely powerful event handling pattern that we study in the next chapter, which is event delegation. Right? Capturing and bubbling allow us to implement one of the most powerful event handling pattern called event delegation. The idea is that we have a lot of element handling similar handle in the similar way, then instead of assigning a handler to each one of them, we put a single handler of their common ancestor. In the handler, we get the event.target to do this. The bar diagram reflecting the ancient Chinese philosopher. Here it is. Northwest, north, northeast, west, center, east, southeast, south, and southeast. The HTML is like this. The table has nice cells, but could be 99, 99, it doesn't matter. Our tag is to highlight a cell TD on click. So on click, you're going to target that, and if that tag is a TD, exactly. So you are now able to capture that element here. And if that, and whoever triggers that, so this will act now as a central point. This act as a central point. Delegation example actions in Markdown. Again, this is not part of today's video, you know. And I know it went too away, all right. But it is part of our understanding, especially when we use now Typescript on the web, to look at this submit event, right? And again, because event is the root elements in the DOM hierarchy, okay? So now it makes a lot of sense for us to now define this as a submit event, which will expose is those property from the event. All right, so as you can see, from this specific event, it has now is only the submitter, okay, who submit that, right? The submitter, and the event in itself will have all of these properties, right? Bubble, cancelable, yada yada, target, type, timestamp. This is interesting because you can actually get the timestamp here, right? And somehow say or run something like this and say, hey, timestamp, the timestamp, which means is that who and when this event was triggered, right? We'll also autocomplete here with the target. It's telling us that, hey, the event target, it can be either exist or null. So it's not assignable to a parameter of the type HTML form. In other words, this event target that can be either that it exists or not is not assignable to a parameter. It's not assignable to a parameter of type HTML form elements or undefined. Type null is not assignable to type HTML elements or undefined. It's interesting because it say that that property might exist or not. So what you can do is something like this, right? And if that exists, all right, something like this. So what you can do is this. Do some check-ins here. Hey, if the target exists, so then this is what I do. This is what I want to do, right? But it says now argument of type event target is not assignable to a parameter of type HTML form. The type event target is missing the following property from the type HTML: accept char set action autocomplete elements. So argument of type event target. Okay, argument of type event target is not assignable to a parameter of type HTML form. So it means that that target, okay, it means that this target here is an event target, but it's not an HTML form element. So somebody here is wrong. Right? Somebody here is wrong. Somebody here is wrong. Because here you're saying is on submit, this event, it is part of the submit event. And then I'm gonna pass down to this submit event. So here it say that this is now a submit event according to this. But then down the line it say, hey, that event that I'm getting you, especially the event.target, does not match with the form data. So does not match with the form data. So, all right. But what I do want is to get that element. Okay, that's the only thing that I want. All right, that's the only thing that I want. So when I click here, and let me now go to the preview, and in preview doesn't show anything. But it say this, somehow the data that I'm passing to the form data is not what is expected, like this. So it is expecting is now a HTML form element. So or now this, which is an event, so or now this, which is a submit event, I somehow need to transform that into a element. And that's interesting because it say that the event target here, it is not assignable to a parameter of HTML form. Okay, like this. The read-only target property of the event interface is a reference to the object onto which the event was dispatched. It is different from the current target, when the event handler is called during the bubbling or capturing the phase of the event. But again, both of them return is okay. Which will refer to the pattern UL in this context. But what if I want to get that element, you know? So somehow here is some mismatch on the type, right? On the shape here. So one way to solve this, right? If that I say, hey, I know what I'm doing, and this, I can use this an alias to do that by saying, hey, ask this, right? I know what I'm doing is that HTML form. Um, it's like overriding that, but that is quite dangerous.
Okay, if you managed to find the solution, well done. You would have noticed that E really did not help us at all. This any annotations seem to actually turn off type checking. You can see that actually we're actually free to do anything we want to this any, and TypeScript will not prevent it. If this was like an object with like a prevent default function on it, default like this void, then we would actually have some autocomplete on it, so prevent default here. But any turns off autocomplete. And so what this means is, in order to fix this error, we have to treat it like JavaScript. And remember, treat it like JavaScript. Think about typos. Think about stupid mistakes you could have made that TypeScript tends to prevent. E.target. Turgid? I don't know what stupid pronunciation I would use there. But if we change this to e.target, then it works. So what has happened here? Well, e typed as any has meant that we have turned off type checking on that e, and it means that it's now assignable to anything and anything is assignable to it. So if we were to find a more sensible type for this, let's say this e that we get on the submit here is actually typed as submit event. We'll talk about where this submit event comes from, but you can actually just type it as submit event here. Oh dear, but this is leading to some sort of error here. Argument of type event target null is not assignable to parameter of type HTML form element. There's something weird going on here. And so you would have to do some fairly advanced stuff in order to get this working. And so someone, I guess me, on this code has just said, okay, fine. To get this working, we're just going to make an any here. And that any is sort of okay in this situation. It makes the type error go away, but of course it exposes us to bugs further down the line. We're going to talk about this a lot more later, but I wanted to give you like an early insight into any, some problems it can cause, and because it's present in a few different global JavaScript and TypeScript APIs. So there you go, any.
Exactly. It's just to presenting that, and I do know that, yeah, makes a lot of sense because they introduced some new advanced stuff here. Prettiest. Okay.
In this exercise, we're going to look at a modify user function. Now, this is a similar challenge to what you may have seen in the past, where you want to map over an array of something and then change something in that array with a certain ID. So here we're taking an array of users, then an ID of the user that we want to change, and then a function which makes that change. So the idea is that we map over each user. If the user ID corresponds to the ID that we want, then we make the change. So the idea is inside make change is you would do some sort of mutation with that user. So let's take a look down here. We basically have modify user, where we have users, the array. We're passing in 1, so this is John here, and we're changing the user from this user here and giving it a name of Vakas instead. And now this modify user here, we shouldn't be allowed to return something which doesn't correspond to the right name there, or doesn't correspond to the right type. So here we're returning name 123. That doesn't correspond with the user name up here. So your job is to work out how to make a type that is a function, because this is what we want. We want to represent make change
a type that is a function.
as a type, which is a function. And that function is going to take in a user and return a user. So that's your job, is to try and figure out what type annotation you can give make change for these errors to go away.
Pretty basically, it's like, what are the type annotation that I need to put in place to make these errors go away? Okay, so you get make change here. And let's take a look at this. It say, hey, parameter make change implicitly has an any type, right? So if I look at where I'm going calling this modify user, where is this? and user. And user has now this. This is when I call my function here. And it say, hey, the user here is any. So in fact, the user is in here is any, right? But now make change, say, hey, the parameter that I'm receiving here, I need to make it explicit. So in other words, this parameter that I'm receiving, which is a function, the shape of this function, which is of course is this function here, but the argument that I'm going to receive, which is now a user of user, right? I'm going to is not returning anything, or in this case I am returning something here. I am returning is now a user, but not a user, by the way. Here with the modifier function, I'm returning is now I'm returning is now is a user. Which is this, right? So it say like, hey, this is to describe now function types. So how you make some annotations to actually match this signature here, right? And if for some reason now we have this kind of stuff, it will say, hey, no, you shouldn't do that. It's a argument of the type user, name, number, and ID is not assignable to a type user. Call signature return type, number, and string, and user are incompatible. So in other words, it's telling that the number in this case, or the name in this case, which is now a number, and the ID, which is now a string, are incompatible. The type number is not assignable to a type string in this property called name. So the idea here is to get yourself familiar reading this type of issues and see the pattern here. So argument of type users like this is not assignable to a parameter of type. So here is describing. So argument of type, which is the value, argument of type user, this one, which is what we are passing to, we modify is the name, value, okay, to be a number, and the ID is just the same as a string, is not assignable to a parameter of the type user here. Call signatures return type is this, and user are incompatible. So find some way to actually fix that particular error, right? You just say, hey, I do 1 is 2, return is a new user. Say elder, right? So now things actually work as expected. So this is just to define its function types. Okay. Function types.
So the way that we annotate a function type on make change here is we first of all say, okay, it's a parameter like normal. And then we can do something like this. Let's just say it's a function that returns any for now. So make change now is described as a function that takes in no arguments and then returns anything. Mm-hmm. Now, what errors is this causing already? Well, we're using make change down here, and make change currently, sure, it's grabbing that type there, which is nice, but it expected 0 arguments but got 1. So how do you add an argument into this type here? Well, just like you would as a function parameter. You say user is user. And now user,
it's a function
what's going on
parameter.
here is we can now return the type that we want as well. So it's currently returning any, but that's giving us an error there because actually we're expecting it to return user, because otherwise this TSExpect error wouldn't be lighting up and we get an error sort of down there. So let's say user, let's make it return user as well. So now when we're doing some modifications in here, we're going to get autocomplete for the things that we want to use here. Very, very cool. And there's one more thing we can do here. We don't have to do this, as you can see, but we can just extract it out into a type of its own, because of course a type alias can be anything. And let's say make change func is a user that returns a user, and now just stick in make change func in here, and that all looks very, very nice. So this is a way that you can express function types for callbacks, for like modification functions like this, and even for typing functions themselves. Very cool.
And the typing event listener.
Let's look at a classic example from the web development world, where we have add click event listener. What we're doing here is we're saying the document, we want to add a click event listener and then pass that listener to it. And what we want to do is when we call it, we want to pass in a function here, and we don't want to return anything from that function. So your job is to, like, this function never receives any arguments here, and we obviously can't pass a string or anything like that. But the challenge here is not that, it's finding out what return type do we want the function to return, because currently it's returning nothing and we never want it to return anything. So your job is to try to find the type that describes that situation best, and then add that to the return type of the function. Good luck.
Exactly, because here it's going to say, hey, my calling is the add click event listener, which just has implicit any type, right? And I'm calling is this. But what I want to do is to now not only pass this, but add click event listener. All right. Typing an event listener. Typing an event listener.
Let's look at a class, but the challenge here is not that, it's finding out what return type do we want the function to return, because currently it's returning nothing and we never want it to return anything. So your job is to try to find the type that describes that situation best, and then add that to the return type of the function. Good luck.
Typing an event listeners. It has any it's a parameter list and implicit has any type. This is the parameter because it's calling this add click event listener. This is now a function that doesn't return anything. In this case is this, used to describe now callbacks. Right, so listener is now a function that doesn't do anything. But it say in this is listener now is a function it's now a function that doesn't return anything. Argument of type void. It's actually pretty descriptive. Argument of type void is not assignable to type of this. But you can do something like this. So again, getting yourself familiar of how this type annotations actually works. So this is how you can define now is callback that doesn't change anything, doesn't return anything. Typing an event listeners. Or you can say function that you have the function interface, and then you say return null. Function is not a genetic. Interesting. But when you want to describe now callback functions, isn't this? Okay, to describe now callback function or function that doesn't return anything.
Okay, so here's the challenge then. If we give this a function type, and let's say we get it to return string, then this isn't good, really, because what we're now going to get an error when we use this, because this is saying type void is not assignable to type string. If we just extract out this function here, and we just say const listener is this, and let's say we pull listener back in there, and we hover over listener here, you can see that this is a function that returns void. If we actually just manually return undefined here, then it's actually going to say, okay, now it's returning undefined. But when it returns nothing, it returns void. So let's just trying out that void up here. Okay, now it's working. So void in TypeScript is basically a way of saying, let's say we just had a result equals listener here, and we hover over listener, or hover over result rather, we can see that this is void. So this is an undefined, which is actually what it would be in JavaScript, right? Because if you were to run this in JavaScript, result would be undefined. But TypeScript has this special void type. And what void says is basically nothing is ever going to be here. Not the value of undefined, but nothing, 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 nothing. So void is a really nice, useful type for these situations where we want our function to return nothing. And just, so again, I think they relax some rules here. Yeah, so like return null is absolutely fine. You can actually like return anything you want from this, but the point is that it will be ignored by the output. So void is really useful for listeners, for any sort of function which like does a side effect or anything like that, where you basically don't care about the output of the function. And void is really, really nice for these situations.
To cover this specific use cases, exactly when you don't want to, okay, I think again, TypeScript is a superset of JavaScript, and when you need to describe specific scenarios like functions retyping nothing, or types and event listener, which is usually you don't return something, there you go. And restricted set type.
This is an interesting little problem in TypeScript. Let's say you have a set here, and this set, you want it to be a set of numbers. Now, you can add a bunch of numbers to this, but this set, it will actually let you add anything you want to. So user IDs here, you can see that we can happily add strings to this. We can happily add objects to this, because there's nothing actually telling this set up here what type it should be inside the set. So if we look at user IDs here, it seems to be a set of unknown. We'll cover what unknown does later, but it basically says, I don't know what this is. It could be anything. So your job is to try to find a way of passing a type to set to basically say you are a set of this thing. Interesting little problem. Good luck with it.
This is when I mentioned earlier about the function types, where you need to explicitly indicate the shape of that container or of that template. So in our case is by passing and say, hey, I do only want to have be this as numbers, and anytime that you want to add something else, it's gonna throw you now some specific error. Say, hey, argument of type string, the value that you're passing right now is not assignable to the parameter that function, in this case the add, is receiving of type number. So add expect now a number value, not a string. So another way to read this is you go from left to right to understand what is the problem. At least when you have this kind of issue, right? Error 2345, error 2345, right? You can say, hey, it's actually now the number, it is expecting number, and exactly. So the parameter of type number of this function that you're calling is not assignable to the arguments that it's receiving. Or another word is that the arguments of this type of this is not assignable to the parameter expecting only to be a number, right? So that is a very interesting way of how you can now use this function types or restricting set type. You can also define this as like this to say, hey, this is now a name of string, right? It will of course not accept that, but when it detect this, it say, hey, now this is valid, but the others does not. And here you can now add several of these sets to JavaScript. And they're going to only add its unique value. So for example, if you do something like this, again, it does this for primitive values. All right. But what happened with objects? Because at the end of the day, objects now are passing here by reference. And anytime you do this, you're creating a new object here. You're reserving a new space in memory. Here you say, now this will be Euler. And then you're going to have here with John, right? And then you have here is Margarita. Okay, and then later on Max. I don't want to include this, right? But for some reason, if we add now twice Margarita, 3 times, right? My question is that what will be is the user's ID, in this case should be renamed as name, but for the sake of example, it's gonna leave that as it is. Oh, there is no need for doing this. Or this one. But I'm not able to see is the console. Right? I'm not able to see the console. Question is, if I want to open up, no, chill. For real. So in any case, you're not showing me that, no problem. Oh, you got it. So I do want to have some or user IDs where now this will be now a new set, and here I'm adding is for the sake of the example, I want to add now Max 3 times and then John, right? And if I inspect what the user's IDs are, right, it's interesting because each one of them now are an independent value. So you're creating, so they act now as an independent. Okay, so each object is like you're creating is a new object here. Okay, makes sense. So if you add now primitive to this set, say 2, and then you add now, for example, 2 again, and there's another one, in this case 3, right? Now the user ID is actually for primitive works. The same for this, right? And this is now comparing is string based of the Unicode points, right? So if you do this, it will also add then uniquely. So far so good, but for objects that doesn't work this way. This go beyond the scope of today's video, all right? But again, this specific data structure allow us to store is unique values, like in a list. All right. Okay. All right. All right. Unique values. Good. 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 Absolutely. 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 Absolutely.
Okay, so the way around this is you basically say, okay, new set. This is like, if we hover over this, you can see that there's a couple of curly, or rather angle braces here. These angle braces have a little unknown in them. And you can see that set unknown is here. Now, we've seen these braces before when we looked at array, and we will again when we look at promises. And these braces basically say, especially when you see it next to like some parentheses here, this is like a function call. Basically what it's saying is you can pass in a type into this slot. This is a type parameter. And what this means is we can actually pass in a type as an argument to set. And when that happens, we can do this. We can say new set number. And now set number, if we look at this, it now corresponds to set number. It creates a set number. And what we can see here is if we try to now add ABC into this, then it's going to error. Argument of type string is not assignable to parameter of type number. So suddenly, by passing in number to set here, it started working. We could also have done this a different way, where we could actually type user IDs here. So we can give a type to the variable. So user IDs, we can say, whatever's in this slot here, it has to be a set of numbers. And so new set here, it sort of infers backwards. TypeScript is so smart in these situations because it knows, okay, I'm putting this set into these user IDs. I better just morph the type slightly so that it works.
Exactly.
If I added like an initializer here and I said, you know, A and B and C, then it reverses. It goes the other way and it says, actually, this doesn't work because you've already put some strings into this set, and so now it's a set of strings, not a set of numbers. But when it's unknown and when it can't quite resolve it, then it basically just says, okay, whatever it's being passed into, it gets the contextual information from there. But this syntax is the one I want you to really keenly pick up on. We've got a new set and we're passing in something, passing in a type argument into a function call. Very, very useful.
Totally. But again, talking about is this function types, right? Makes a lot of sense here. Type checking maps.
Okay, a similar setup to last time. Now we have a map instead of a set. And a map is slightly different because it's basically a dictionary. So it stores keys inside the map, and then on those keys it adds a value. So here on the 1 key, we're setting name Max age 30. On the 2 key, we're setting name Manuel age 31. Same with Anna down here, except we're expecting an error because you can, in this particular map, what we're using, you can only pass in number as the key. So your job is to, very similar to the set, is to try to work out a way that we can type this map here. We take a little look there, you might see a couple of little type arguments there, and you might have to do some guesswork to work out which is the key and which is the value. But I think I've given you all the information, and maybe a bit too much for this exercise, but I reckon you can do it. Good luck.
So again, this is special data structure. All of this comes from the ECMAScript, right? ECMAScript 2026, like this, where here we can explore. This is 2026. That's right. Is now some of these additional features that are present in the language. So not only the fundamental objects, all right. So like object in itself, a function object, Boolean object, symbols, numbers, as well. The big int, the math objects, the date, the text processing, whether it's using a string and the regular expressions, the indexes collection, whether it's using an array or the indexes collections, whether it's using that or type array or even unsigned 8 array objects. The key collection, this is when you have now the key value pair, right? This is interesting because now not only map is one of them, but also is the set as well, right? And set objects are a collection of ECMAScript value, and a set may contain each distinct value at most once. Distinct values are discriminated using the semantic of the same value zero comparison. If you take a look at that, what in the French scope is this abstract operation? As you can see, this abstract operation or things that JavaScript automatically do that for us to guarantee it is consistency. It said the abstract operation of same value 0 takes argument x and ECMAScript value and g and ECMAScript value and returns a boolean. It determines whether or not two arguments are the same value, ignoring the difference between positive and negative. So it performed the following step. If they have the same type, so it is false, aka this comparison that is doing, especially on objects, right? When you take a look at this, hey, if they are the same type, undefined and undefined are true, null and null are the same type, booleans, number, big int, string, and even object, all right, if an x object and a g object is an object, return true, otherwise returned false. And here's the thing. So if I'm passing you now, if they have the same type, for example, like this, right? Same value 0 comparison algorithm, set object must be implemented using either a hash table or other mechanism that on average provide access time that are sublinear on the number of elements in the collection. The data structure used in this specification is only intended to describe the requirement observable semantic as set object. It's not intended to be a viable implementation model. So it's up to the JavaScript engines developers to do that. So abstract operation for set object. Set record is a record value used to encapsulate the interface of a set or similar object. And this is the behavior that must have, right? But again, it says that distinct values are discriminated using the semantic of the same value comparison algorithm. So if both objects are in the same type, right? If same type is false, return false. If one of them is a number, right? Then return the number same value. Or same value num number, which is in this case. Same value num number. This same value num number, the abstract operation same value num number takes arguments of ECMAScript value but not a number, and ECMAScript language value but not a number, and returns a boolean. And it performed the following step when called. So if in our case, what we care about if that is an object. So if the same time is true, right? In this case, if one of them is an object and the other is an object, if this is true, return true. If x is either undefined or null, return true. If x is a big int, then call this. If it's a string or if it is a boolean, is this. Note, all ECMAScript values are comparing by identity. This is the crucial part of this. All ECMAScript values are compared by identity. In other words, they are comparing if they are the same value, not by content. This is why when you're adding these new values, especially as an object, it's going to compare that based on its identity, not its content. It is telling you, it is telling you. So set, so using set and store objects inside of that, as long as they have the same reference, then it's not going to be added there. But if you are now on each one of those creating or passing a new object or creating a new object, reserving space in memory, so they are now on a different identity, aka on a different space in memory. This is when things get a little bit trickier, and I don't want to trip people around this, not at all. What this identity comparison means is similar that when you compare the number 42 in any different numeric system, no matter how that is represented, all of them points to the same single unit. And this is the idea around this, right? So there is no 42-ish. It is 42. You know, there is no Euler. There is one Euler, right? Or one John, or Peter, or James, or Lee, Enrique, or Matt. You get the idea, right? Holy moly. Okay. But again, it's comparing by identity. So now the mystery has been solved. The mystery is solved. Okay. Good. Good. Okay, it's comparing by identity. And here we are. Alright. Okay. So when you do this kind of stuff here, again, we're using now is a map, but when you do that on a set, each one of these elements, they're gonna be added as set object, right? A set may contain each distinct value at most once. But if you use now an object and you pass now object with the same content, that's not the same as the identity, because the comparison here is based on its identity, not its equality, not its content. So that's what I written this up a little bit, right? So mystery solved. There you got it. Jesus French toast. There is a lot of nuance, and you need to do this in a very systematic way. I think this is the way that there is. What other how what other ways do you think that if you want to find out the truth of something, you will do that? All right, just because you naturally come with that. So in any case, that makes a lot of sense here. And again here, because now map on like set which is index collection. All right, it's an index collection. That's interesting that they call here as a key collection, but in any case, that act more like that. Um, but in any case, this is part of the hidden method, right? Set data index. But in any case, this is how this thing is working. The set, the property, the prototype. Yeah, I don't know. I don't know how many people actually read the ECMAScript, because people from the C++, C sharp, they know that. They have to read the spec, bro. It's like, that makes a lot of sense. Um, okay, so this is all the other property that you can act upon this. And yeah, yeah, they call here now map as key collections. You have now a key and a value, and the value can be any other type. It can be a set, it can be an array, a function, and another primitive value as well. It can even also another object as well, right? It can be now a weak map as well, like this. And the weak map are collections of key value pairs where the key are objects and or symbols, and values may be arbitrary ECMAScript values, unlike now map here, where both key and values may be arbitrary values. Okay, a distinct key value may only occur in one key value pair within the maps collection. Distinctive values are discriminated using the semantic of same value zero, so they are being compared by this identity. But here you can is used for both key and value pairs, any arbitrary type. But for weak map, where the keys are objects and or symbols, and values may be arbitrary, so a weak map may be queried to see if a counting of a key value pair with a specific key, but no mechanism is provided for enumerating the value it holds as a key. That might go beyond the scope of today's video, right? Something like weak map and weak set. Yeah. The other is a structured data. Structured data, array buffers, share array buffer objects, data view objects, the atomic object, structured data. Okay, the JSON object is interesting. They call this a structure. And then you have other things like managing memory and so on. So in control abstract operation, which you have is the iterator and the generators and the promise and yeah, that kind of stuff. Control abstract objects is like, hey, how do you now is pass control from one piece of execution to another, from one part of the program to another. And then you have now the reflections, proxy object, and the memory model as it is. Okay, race, and that. Okay. Anyway, going back to this. Where we are. There you go. Okay. Has actually solved a lot of the mystery. So here you can specify is this, or the shape of the type that this map has, that each, so the shape of this map that each one of these element has, and that is the name, which is now a string, and then you have is a string, and then you have the age, which is a number, right? And this actually match here, but it say, hey, there's something here. No overload expected here. Oh, that's interesting. I just barely read about this, but it tells me here it's like no overload expect one type argument. It expect 0 or at least 2. That's right. For the key, indexed key collection, which is, hey, this is now a string, comma, the shape of the value. So now things started to make a lot of sense here. You can also say, hey, you know what? Let's make this much more simple. Okay, by saying, hey, this is now the user type user, right? And the shape of this will be this, right? So it'll be now a string as the key. And then you can pass down here to actually map that. It might say, no, I don't expect that. In fact, I need you to be more explicit about that. And what I can say is, since this is now the map user, all right, and the signature it expect is of now these two arguments, right? So by map user, right? But it doesn't reflect that. Map user only refers to a type, but it's being used as a value. So what I can do here is somehow I need to define is that this is the, let me put it here like this. This is the user, right? Put it here. So this is the user, but it need now a string, right? So for this kind of Jesus, okay, makes sense. Makes a lot of sense. This must be a number, and there you got it, right? So let's take a look at the solution here.
Okay, look, I've added a few different solutions here, but there's one main one you need to get. You can see I've added a type user at the top here, just for convenience for later. And this map now, we can see that it's got an any on it. And by a little bit of guesswork, we can see that if we pass in number and user, it will start to go away. You can see a little bit of autocomplete there. If we hover over number here, or actually while we're typing, number, user, yeah, you can see that there's a K and a V in those little slots here. And those K and V, that represents key and value. So map now, we can go for number and user, and now it starts working. So we can no longer pass in, ABC into this this set function here. And also when we get stuff from it, so let's say const result equals user map.get, we have to pass in a number, as you can see from this overlay. So 1, and we get back user or undefined. If we didn't do this, then it would actually be typed as something different here. So yeah, it wouldn't be typed as user. So that's the first method. We've also got, of course, we can do this inline as well. We don't have to declare the user object outside. Or we could do it in the method we discussed before. So we could say user map is a map, and then we don't need to pass in any keys, or any type arguments rather, to this new map up the top here. So that's another way of doing it. Or of course we could just, I've given you all the possible solutions here. That's very nice of me, isn't it? So we've got map, number, and user or as a variable annotation there, and we've extracted the type outside it. So again, just passing type arguments to functions is just so useful, and it comes up a lot more than you think.
Yeah, absolutely. For type checking map. And then debugging JSON parsing.
In this code here, we are JSON.parsing some JSON here. And this JSON has a name of Alice and an age of 30 on it. And we're passing as well a type argument to JSON.parse, name and age here. And we're expecting the parse data to be typed as kind of name, age, number, what we've got here. But it's not, it's typed as something else. And your job here is to basically figure out why that's happening and decode the errors that are happening up here and see if you can find an alternative way of expressing this that makes the type errors go away. Good luck.
So essentially here what it's saying is I expect 0 type arguments, but I got 1. AKA JSON parser here it say it is expecting at least is a okay it is expecting at least this is the extreme, all right, in a reviver, which is another function, and it's returning now any. So what we can do here is to be explicit about this, right? Or expect 0 type arguments but got 1. So it actually is descriptive about this, right? So what you can say is, hey, the type annotation will be this, right? This might be one way to do that. So you make sure that the parsing is what it is. Or you can now annotate an alias, and this might be something quite dangerous. You can do something like this as well, right? So you are explicitly telling Typescript, no, you don't know what you're doing, I do. This is the shape of the data. And let's take a look now at this exit or this problem here. It say type false does not satisfy the constraint true, which is type false, and yes, it is. So because now parser here is saying I'm going to return any of this. So yeah, if you are sure that you are going to get this data as it is, all right, you can either is using a type alias like that, or you now explicitly tell Typescript this is the annotation of this value. But let's see if there is another alternative here.
Let's start by decoding the error that we're getting on the type argument of JSON.parse. We have expected 0 type arguments but got 1. That's indicating that it's not expecting to be passed anything inside these curly or these angle braces. So let's remove this. So now, wow, it's happy, fantastic. But you can see that the parse data is typed as any. This is because if we hover over JSON.parse, it always returns any. It's a bit of a troubling thing actually with sort of TypeScript and JSON.parse, but we will talk about that later. But how do we get around that? Because we actually want our parse data to be the correct type. Well, we know that any is assignable to anything and anything is assignable to any. So that means that we can actually just pull in this and just say parse data is this type. So parse data now, we've given it a variable type annotation with name, string, and age number, and everything is working great. And because it's actually being parsed any, it's pretty happy with this. So this is a way that you can get around JSON.parse not accepting any type arguments, and because we can see here that it doesn't have any angle brackets on this little section there just before the parentheses. So some functions will take in type arguments and some functions just won't. And your job is to try to get around that sometimes.
So some functions will have to receive is the type, and some others no. So they are not dynamic. And then typing fetch API response in async function. Oh, this is another one. This is part of the essentials. Of course.
In this exercise, we're going to look at an async function for the first time and start handling promises. We can see that inside fetch data, this function, we have a response, and that response is coming from await fetch, and we're just fetching some example data. And this response then, it's a response type, which is a globally available type. And we're calling response.json on it, which returns promise any there. So we hover over that, we can see it's returning promise any, and that means that data ends up as any. If we remove...
Wait, what?
In this exercise, we're going to look at an async function for the first time and start handling promises. We can see that inside fetch data, this function, we have a response, and that response is coming from await fetch, and we're just fetching some example data. And this response then, it's a response type, which is a globally available type. And we're calling response.json on it, which returns promise any there. So we hover over that, we can see it's returning promise any, and that means that data ends up as any. If we remove this await there, it actually is promise any, which is kind of interesting. So that's worth bearing in mind. Now except this data that we're fetching, it's actually just going to give us a number. So your job is to try to work out how you can make data typed as a number without changing any of this code down here. So this is the only code that you're going to be changing. So there are a few ways around this. One involves adding a type to fetch data itself. One involves typing data itself. And because we're dealing with any, it's going to be fairly flexible in the types that you can add. Good luck.
So the idea here is to say, hey, what is the data that this piece of data must be is a JSON, which must be is a number, right? So this data here that is awaiting from this promise of any. So here you can now explicitly to whatever this function returns. In this case, the type of value that it returns is a promise. I can now explicitly say the number here, right? So it's a hey spec 0 type argument but go 1. So it means that does not like this. All right. But what this is returning is now a promise of any. Okay, that's interesting. How do we annotate it? So at the end of the day, this is now an any, or at least is in this case, right? So when we fetch some piece of data, but this data that we're getting here, right, that actually is coming from that, which is now a response, right? Is part of the data that we're getting from this, and then the data that we're getting from this is now a promise. So how can we now put some annotation to say, hey, this is now a number? You know what I mean? What is the annotation for this, right? The body.json, what is the annotation for this? Or you either say that this is now a number, which of course it solves that particular issue. So you are explicit about the type of this value, this container, this variable. What you can do is as this. Say, hey, as number. And you are now making sure that you are returning is that the value that you're getting here is now a number. But there are a couple of things here. So this is now promise. Okay? And because this is now a promise, right? If we remove this, so since this is now is a promise, so here we're receiving is now a promise of data, right? Again, in order to solve this issue, I will say that we can now is explicitly describe the value here. That at the end of the day, this is now a data or a number.
Okay, let's take a look at a few of the different solutions here. The first one that comes to mind is you might be thinking, well, shouldn't I be able to pass a type argument to fetch, similar to map or set? Well, no, unfortunately, just like JSON.parse, this is one of the ones that you can't add a type annotation to. How about .json? Maybe I could be able to pass in like this one inside here, but no, expected 0 type arguments, but got 1. So it's not expecting to be passed a type argument. So then, what we could do, certainly a very nice way to do it, is by saying data is number.
Being explicit about it.
This works because data was any before, and this await response.json returns any. So now what we're doing is we're basically just putting any into a slot that requires a number, and it's happy. So that's one way to do it. The way that I recommend you do it, though, is by adding a return type to this function. So what we can do is, after these little parentheses here, we can add a return type, and we can say fetch data returns number. Okay, now we're getting somewhere. Now data is typed as number, except there's an error up here. The return type of an async functional method must be the global promise type. Did you mean to write promise number? Amazing. This is an extremely rare, very, very good error message from TypeScript. And it's basically saying you should use promise number instead. Because if we weren't to await this, for instance, and we still had this number set up there, then TypeScript would infer this as a number. But in fact, we still have to await that. Like, we need to await fetch data for it to be worth anything. So by wrapping it in promise, it makes sure that this data is awaited before it can be figured out. So we've got await, not awaited, what am I doing? Await fetch data. Now make sure that this data is typed as a number. And this is kind of like the same thing. Data here is typed as any. And so when we return any from this fetch data, it's not going to yell at us. Whereas if this was typed as string, for instance, then it would yell at us because type string is not assignable to type number, which is what we're saying we pass back. So these return types are really useful because they let you say on the function itself what the function is supposed to return. And TypeScript will enforce that. Pretty cool. Shit. Let's talk about.
All right, so now let's take a look at the integrated development environment superpowers. Good, good.
How TypeScript works when you're in your IDE. You can kind of think of two people looking at your code whenever you're writing TypeScript code. You've got you and you've got the TypeScript server. Now, you're both running on VS Code, let's say. This can happen in any IDE, but I'm going to use VS Code as the primary example because it's very clean and you're probably using VS Code. So when you open VS Code, the TypeScript server starts in the background, and it sort of sits there as a background process just watching whatever's happening in your IDE. Now, when you change a file, then TypeScript server will check your code, and if it sees any errors with that code, it tells VS Code to show a red line. Then, when you go on to fix the error, it'll then check again and say no more error, and the red line disappears. And it will only stop when you close VS Code. So the TypeScript server is basically the thing that powers everything inside VS Code when it comes to TypeScript. So when it comes to hovers, when it comes to autocomplete, all of the in IDE things that you see with VS Code, that's what's driving them. So you can think of there being a copilot next to you, not GitHub copilots, but the TypeScript server as the thing riding next to you, checking your work as you go.
Introspecting variables and declaration in TypeScript.
One of the coolest things that the TS server gives us is the ability to just introspect variables and declarations in TypeScript. So if we want to know what the type of, let's say, this thing here is, we can see that it's got this let thing number. And this is really, really good when we're investigating really complex pieces of code. So for instance, we've got an object here and we can hover over that and we can see that it's let name string there. But if we, for instance, let's say we go const other object and we say, let's just spread in other thing into here, and we'll just say, let's put the other thing in here too. We can now hover over this and it will give us a computed readout of all of the items that are in there. This is super duper useful. It also means too that we can, like, it depends on what you're hovering over. Let me just say thing here. Like if you've got a multiple dot notated item like this, then you can either hover over other objects here and you can see the whole object, or you can hover over just the thing here and it will tell you what that property is. So you should really get used to this ability in TypeScript of just kind of floating around, looking at what all of the types are, because it's going to give you really amazing metadata and help you understand what your code is doing.
But this is introspection variables and declaration in TypeScript. Hovering over a function call.
Let's put our hover skills to the test. Here we have a very simple piece of code where we're grabbing an element by document.getElementById, and we're expecting to grab an element by ID of 12. But for some reason we're getting an error here. That's no fun. So what I'd like you to do is investigate what type document.getElementById actually requires, and then also, just for a little bonus one, check what type element is too. Good luck.
So it's like hovering on function call to look at the signatures. Like this. And all of this is running by the TypeScript server, where now it show here is this this nice little box outlining this. Okay, get element by ID and the element ID, which is an string, and it's going to return is either null because it couldn't find it. Yeah, it couldn't. Yeah, it couldn't. Yeah, because it couldn't find it, or the actual element here. But all of this is part of the of what the TypeScript server is allowing you to do and what it
Okay, so hovers can help here in a bunch of different ways. First of all, we can hover over the error itself here, and this will actually tell us what's going on. Argument of type string or number is not assignable to parameter of type string. And we'll even here get a readout of this getElementById here. So what's happening is if we look at this, you may know, like just off the top of your head, that getElementById requires a string. Great. But if you weren't sure, And let's say this was an external library that you'd really never used before. Just hover over getElementById and you can see it's a method, first of all, and we've got document.getElementById, and the element ID it requires is a string, so it requires string. So just by seeing that red line and actually just doing a bit of contextual hovering, we don't even need to read the error message, which is amazing. And the thing that it returns here is HTML element or null. So that's what that means. So this is what this element is, HTML element or null. Very cool. So we know now, given that we can just sort of scan over all of this stuff, and by the way, the other thing that we didn't hover is documents. Var documents, documents. And you notice with the stuff that comes from the DOM, we actually get a little MDN reference here that we can go and click to, and we can just go and see the MDN reference for this thing, in this case, which is documents, which is the globally available document thing that you can add stuff to do some DOM manipulation. So in order to fix this, we just change this to a string, and now everything's happy. Beautiful.
Adding documentation for hovers.
Another thing that's really useful about TypeScript is it lets you build in automatic documentation for your functions and variables.
Exactly, which is part
What
of this.
we want to do here is we have a function which is just adding two numbers together. And what I'd like you to do is by using something called JSDoc comments, sometimes you'll find them as TSDoc
yes.
comments too, is I want you to add a comment above the function that just describes what it does. And this is just adds two numbers together, for instance. And you'll see when you hover over that function, something very interesting will occur. Good luck.
My function is declare, and it can give you is the signature here. So it's already, again, there is no need for us to copy that and use that. But what is this TypeScript server is doing is not only help us to highlight some variables and its property, but also is so introspecting these variables and declarations in JavaScript and the values of those containers, or aka a variable, and then look at the anatomy or look at the shape of that method when we hover on. And the also is when we hover now on functions or in annotations here.
Okay, let's do it. Here's one I prepared earlier. I'm going to add a comment above this that just says it adds two numbers together. And it's also got this little example tag too, which I'll show you in a second. And now, whenever I use my function here, so I'll call it with, two numbers here. First of all, what we see is when we go to actually type in the numbers here, it shows us exactly the signature of the function we expect, and it gives us the comment there immediately, adds two numbers together. And we've even got an example usage with full syntax highlighting as well. How amazing is that? So this example tag basically means that anything below the example will be considered an example, and it will be syntax highlighted. So we can even add some stuff in here saying, wow, so cool. And it will be shown, where is it, just here? There you go, it's getting a bit crowded here because we've got the error translations coming as well.
Example.
So this one here, it says, my function adds two numbers together, example, and it's even got the syntax highlighted stuff at the bottom too. So this was actually one of the reasons I fell in love with TypeScript, first of all, is because it just gives you so many tools to really say what your code is doing to other people and communicate.
Exactly.
But of course, that's only present if you know how to hover these and how to introspect all of this information. But so gorgeous. So if you're building any kind of library or even some util functions that are designed to be consumed by other people and used by other people, and of course whose code is just designed to be used by themselves, you're all working in teams professionally, then JS.comments, CS.comments, there's a whole world of stuff out there that you can look at to kind of bring this information front and center when people are using your code.
Absolutely, especially adding documentation for hover, of course, on examples here. That'll be all for this video. All right. Yeah, man. Absolutely useful for that. And manually triggering autocomplete Well,
Autocomplete is one of the
autocomplete
coolest features of TypeScript. Sometimes I'm really not sure how I ever coded without it. Autocomplete can sometimes be a little bit tricky though. For instance, when you have, let's say,
But in any case, that'll be all for this video. So, take care. Bye bye.